truth.
So,
There we go. Yes, perfect.
yeah. Do you need to start streaming or anything?
All done.
All done.
All ready for you. I always trim the beginnings off.
All right. All right. I'll compose myself. Okay. Hello everyone. I'm Mike Irving. I live in Macclesfield. I work for Clipboard and Microsoft MVP, and I'm here to speak to you about a system that kind of came about by accident, with no plan, no agenda, evolved fluidly, and rightly or wrongly, and yeah, here we are. I co-organise a similar group in Macclesfield called Macc, which is kind of tech agnostic. Also used to meet in a pub when we first started, and I co-organise the .NET group in Manchester, which is a larger group. We sort of get 50 or 60 people for a .NET-y type talk, and yeah, you can find me at the usual sorts of places, and I occasionally write a blog, and this story kind of began with a blog at one point in time. So, to set the scene, we had a ridiculously hot summer 3 years ago, 2022, and the temperature was kind of pushing 40 degrees, and it was 30 odd degrees in our house at night, so we were sat relaxing in the garden because you can't sleep. We had a gazebo up, and we heard this scurrying sound across the garden, and had a look, and it was a hedgehog. And we knew there was hedgehogs in the area. We'd seen them kind of in headlights when you'd come into the road, occasionally scurrying off, but we'd never seen one sort of within meters. And I grabbed my phone and filmed it extremely badly. This is a heavily brightened picture of a still of it in the middle there. And yeah, it was quite a revelation. There's hedgehogs in the garden. So what to do about this? Well, we at home have these Arlo home security cameras. It's quite a nice sort of home CCTV system. So I fetched one of these down, and I got hold of this hedgehog food, and it's a wet food. It's a bit like a cat or a dog food. Spike's hedgehog food, scrummy meaty supper. And yeah, got hold of this, and I set up this little area where I'd got the Arlo on a bendy tripod attached to a child slide, pointing at a bowl of food and a bowl of water, and thought, let's see what this can capture. So we got footage the very next night. So this was the first footage. Hedgehog arrived and ate the food. Great. So this happened for 2 or 3 nights, but then the local cats got wise of it, and there was one time I put the food out, went inside, washed my hands, came back to the window. It must have been about 2 minutes, and it was gone. So yeah, I needed to do something about this. So the initial solution was, we'll put it in sort of a leafy area, and I put bits of holly about to stop the cat. And this again worked for 2 or 3 nights, but then you just got the cats kind of leaning over it and getting it anyway. So yeah, not a proper solution. So a better setup was needed. There's another town near Macclesfield called Bollington, and there's a charity shop there called the Bridgend Centre, which has a woodworking centre, and adults make bird tables and things, and they go up for sale. And I went in one day, and they had this hedgehog house, and on the right hand side it's got a little entrance, and the hedgehog has to do quite a few turns to actually get into the main chamber, and cats won't do that, so it's kind of cat proof. So that was an instant decision. I'll have that. And I'd acquired this camera by this point. These things are called field cameras, and they're supposed to go on trees in the countryside and record birds and things, and you turn up with your mobile phone, connect to it, and see what's on it. So I mounted that, it's quite big, mounted that inside the hedgehog house and took an exciting picture of a spanner. Put the food and water bowls inside, and there was a bit of a wait. I guess it didn't smell right at first. Brand new piece of wood, and had cleared out this area of the garden as well. And after a few days, we got mice, and then we got hedgehogs. So this is the first guest, and I'd moved the Arlo pointing at it by this point, and made a little gap in the fence, and the hedgehog goes through, and then from the inside, the hedgehog comes in and eats the food. So I had no idea about the camera angle or that sort of thing at this point, but this was the first footage, and this was fantastic to see, because I never really appreciated what they actually looked like, kind of up close, and brilliant. So we started experimenting with this. They were coming regularly, but not every single night, and the food was messy. It was this wet cat food type stuff, and they wouldn't come every night, so it would get wasted, and there'd be flies because it was still 30 odd degrees, and they're quite clumsy as well, so they'd knock it over. So I went on the Hedgehog Trust website, and it says you can use cat or dog biscuits, meat based, but don't use fish based ones, because hedgehogs don't come across fish naturally. So we settled on this one from the co-op, Go-Cat, duck and chicken, and I'd got these two other cameras by this point, this little white one and sort of another home security type one, and I put the little white one in the hedgehog house instead, because it's only about that big, instead of a field camera that was kind of too big for the house. And yeah, we started to get some good footage. So this is just a selection, but this one, hedgehog comes in and just tips the bowl up, and this demonstrates what happens with bits of food going everywhere, because you can imagine what it's like the next morning. This one's quite good. There's a hedgehog trying to leave the hedgehog house, and there's another one at the back. It makes no effort whatsoever to move out of the way, just carries on eating, and the first hedgehog does manage to leave at some point, and there's even then no acknowledgement that this has just taken place. And then this one's good. Hedgehog comes in, I guess can sniff the food, can find it, and thinks, I think I'll have that, and just yoinks the bowl. So yeah, we were getting some good footage, but what has this got to do with programming? Well, the inner programmer in me was thinking, like, well, what can I do about this? How can I improve this? It was getting time consuming. There was 4 cameras, all controlled by different mobile apps. I was bringing in SD cards and removing files off them, examining the contents of the files, because most of it was just rubbish, like a trick of a light or a fly, or really just nothing. Charging batteries, all of which were different for the different cameras, and the storage space was a big problem, because they were all going on this laptop at the time, and it was rapidly running out of disk space, tens of gigabytes of MP4 files. So yeah, what can I do about this? Well, this just compares the cameras just to highlight the problem, and so they're all different. The Arlo, it's a great home security system, but the communication's kind of proprietary, private, and that particular one runs on these 123 batteries that used to go in compact cameras, but the newer ones are rechargeable. The field camera records to an SD card. It's got a lithium battery and a solar panel, or you can have AA batteries in it as well, so you really can leave it for months on end somewhere. And it's got its own Wi-Fi network, because the idea is you turn up with your phone and you connect and you have a look in the middle of nowhere. The other 2 go on your local Wi-Fi, so they are home cameras. Again, they record to an SD card. This one's got a lithium battery and a solar panel. The little white one hasn't. I got around that by strapping it to a small battery pack, but the size of it was ideal, because it was tiny, but they're all different. Nothing common about them. So I thought the 2 local Wi-Fi cameras, let's see if I can break into those. Well, I was prepared to connect by any method, web connection, SSH, FTP, anything like that. So I looked up likely ports on the internet, and then I found this tool from Microsoft called Port Query, and you can either tell this I'm interested in this particular type of connection, go and find it, or you can give it a specific port range and say find anything that's listening, and it's time consuming and kind of interesting what it finds, but it drew a blank on these two cameras, so paused that for the moment, and I turned my attention to the field camera, this one, and this uses the mobile app that it comes with, and you go into the field and you press connect, and it sends a command to the camera over Bluetooth Low Energy, and then once that's been accepted, the Wi-Fi network suddenly appears and you can connect to it. So I went on, I noticed that you could connect with the mobile app, but then the Wi-Fi network would show on your PC. So I did that and then connected on the PC, knew the password because that's on the SD card in the settings file, and I realised once it was on PC, it had a web interface on port 80. It listed all the files, it had a download and a delete option, and I thought I can do something with this. So I started a project called Camera Experiments, a code project. And the first thing I wanted to do was replicate the Wi-Fi connection. So I could use the app to enable the Wi-Fi, but then I wanted to connect via the PC. So I wrote some C# code to do that. It can connect to any Wi-Fi network, and it uses this package, Simple Wi-Fi, and it can connect to the camera's Wi-Fi, but also switch back to the local Wi-Fi, the home Wi-Fi. And you do need retries and delays in the process, because you do the wake up thing from the mobile app, and it doesn't always appear immediately, or it does appear but doesn't connect immediately. So you might have to do 2 or 3 attempts to connect with delays. There's a bit of code here that you probably won't be able to read, but it says give me all the access points, and if it's the one with the known SSID, then create this thing called an auth request, and then you can say, well, if it's not already connected, is the password required? And you can say, has it already got a profile? So does Windows already know what it is? If so, just connect. If it doesn't, then give it the password and it connects. Again, with this degree of volatility to it. But yeah, what about the Bluetooth bit? Because this is kind of a bit clumsy, because I still need to sit there with the mobile app that comes with the camera to turn the thing on in the first place. So I found some Python code on GitHub for not the same camera but a similar camera, and I thought, can I reprogram this in C#? Now Bluetooth isn't my cup of tea. It's not something I'd done previously. So I tried to get something working, and I spoke to Peter Foote, who is another MVP, and he's the Bluetooth guy. And between us, we reprogrammed this code into C#, and it uses his package in hand.bluetooth.le. So I could now successfully issue the Bluetooth command and activate the Wi-Fi network, and then run the Wi-Fi connection code. And again, it needed delays and retries because it doesn't always happen immediately. A similar sort of code there that you won't be able to read, and it's saying give me scan for devices. If it's a device we know about, then you can get a list of services. So this is the Bluetooth terminology I had no idea about. And get the primary service, and then if that works, slight delay, then get the characteristics from the service. Again, Bluetooth terminology. And then for the first service in the list, send this string, which came from the Python example, and then it wakes up. So, great. The files needed some consideration as well. So I found the web interface had an alternative URL that gave me an XML list instead. and I was much happier to work with that than kind of scraping a web page, because we're structured. It's not going to randomly change because of paging or anything like that the web interface might do. So I wrote some code to parse the list, download, and then delete each file from the camera. And I needed to set the correct date and time, because if you trigger a download, it assumes the date and time of right now. And the files were called like 1.mp4, 2.mp4, so that was kind of not very helpful. But the XML had the correct date and time in, so I came up with this file name format of reverse date, time, the camera, because I always wanted to extend this to the other cameras at some point, and then the original file name. And then sortable if you do anything in reverse date time. And yeah, there's some code, but it's just getting the But I was doing a lot of this work very specific to this one camera at the moment, and I didn't want this. I wanted to be able to bring the other cameras on board at some point, so I came up with this JSON. It's not very exciting. It identifies this camera over CY95. It attempts the Bluetooth activation, achieves it, disconnects the home Wi-Fi, connects to the camera's Wi-Fi on the second attempt, it would seem, and then waits, because it's not immediately responding once you connect to Wi-Fi network, and then it can pull down the MP4 files. And at this point I stuck it on GitHub and called it Camera Experiments. But yeah, the actual files were still being pulled down onto this laptop at the time, tens of gigabytes of them. So I thought, well, where can I put these? I'll put them on the web somewhere. I'll have this website, Macclesfield Hedgehogs. I didn't really want to put tens of gigabytes of MP4 files on a web server, so where's more intelligent to put those? I thought, well, I'll put them in Amazon S3 bucket storage, because I've done a lot of work with that in the past. And I had this concept of automated, approved and unapproved footage. So automated would be files that had come through this programmatic process with the Bluetooth and Wi-Fi. Approved would be stuff off the PC that had already gone through and said, yeah, that's Hedgehogs, delete all the cats, delete this, I want this footage. And unapproved was the big bulk of everything else that was still sat on here that would need sorting at some point. So approved would be public immediately, and the unapproved would need to be approved in some way. And then I needed a list of stuff from S3 to be read by the website. So I started another project called S3 Bucket Experiments. Started with the Visual SDK from AWS for .NET, and I wrote functionality for uploading, moving and generating a list. So the moving was I had the public folder and I had the unapproved folder, and I needed a way of moving something from one to the other. And on the PC I set this structure up. There was a folder called cameras, and then I could define any camera underneath that, underneath the camera folder. So approved, unapproved, automated. And then when the program ran, it would deal with these files in a slightly different way, depending on whether they were to go live or not. And they were all optional. So if it found a new camera and it only had one folder, then it would deal with it. And again, it was a console app, and yeah, it switches to the Arlo folder at the top, and then it switches to the CY95 folder because there's nothing in the Arlo folder, and it starts to upload the files to the bucket. And at this point, I put this on GitHub as well. Now I needed to do something with all these mass of files that could have had anything on them or nothing at all. I thought I'll put a private web page on my website backend, and I want to be able to approve or delete files that had either come through the automated process or had gone from an unapproved folder on the PC. So I wrote an AWS Lambda function, a serverless function in C# to approve files and then move them to the main folder and then regenerate the list for the website. So it kind of still looks like this. You get loads of sort of stuff working with buckets and other files, but I still needed to write the website, and it's a single page application. It's vanilla HTML, JavaScript, CSS with jQuery. Makes use of Jekyll, which runs on GitHub pages. It just allows you to do things like include files, and it's often used for static blogs and that sort of thing, so made use of that a little bit. And it reads the feed from Amazon S3 and it spits out the website, and yeah, that was how it looked initially. It was mobile enabled. Initially it was at Macclesfield hedgehogs.co.uk, and it's now not, for reasons that I'll explain later. But I got this up online on the 3rd of December 2022 because I'd agreed to have an entry in the .NET Advent calendar on the 5th of December. So on the 4th of December I wrote an article about this on my website, and it was published on the .NET Advent calendar on the 5th. And again, this isn't online anymore, but when it did go online and it was shared massively over social media, it went big. I was getting loads of good feedback. People from Microsoft, people loved it. There was loads of suggestions coming in. Oh, you could change this, you could do this. What a great idea, and that lifted me. And unfortunately, the Hedgehogs spoke party because they'd started hibernating by this point. This was the last known footage of one scurrying off. I think this is Christmas Eve, 22. And in the meantime, there was loads of mice coming, which was fine. So I thought I'd use this downtime to kind of improve the system and work on things that I wanted to get done but never did. So post-launch changes, I wanted video thumbnails and some website alterations. I always wanted this thing to run on a Raspberry Pi or some other device, and not have to rely on the computer being on to run all this stuff. I wanted further automation, and I wanted alerts for when things fail, because things do fail on the automated process, and much more came that summer. So video thumbnails. Having no video thumbnails is a bit of a problem. It's okay if you've got a web page with one video embedded, but what the browser has to do is start to download the file, examine it, and then create a thumbnail and then squirt it back into the HTML. So there's a network hit, and then there's a CPU hit to generate this thing, and it's alright if you've got one video, but if you've got a page with 20 on, that's a big ask, and that could be a mobile device on mobile data. And S3 was saying as well, 403 forbidden. Like, you can't request 25 files at once. You're clearly a bot. So needed to sort this out. Now, the dirty fix was to show 5 at a time, let the browser do its thing, create the thumbnails, and then by the time you've rolled down, there's a little plus button, and I'll show 5 more, and you'll carry on. But it's not a proper solution. The proper solution is to supply a graphic. So you use the poster attribute on the video HTML video tag. Some graphic represents some video. But how we're going to create those? Well, I had a look what other people were doing, and I had a look on NuGet, the .NET package manager, and most of the packages doing this, we utilising this thing called FFmpeg, and this is an open source video manipulation software that can be used for resizing, trimming, joining videos and various other things, and these packages utilised it. So you could install this FFmpeg on your local machine and then add the package to your project, and then the package will use the software. Pick this one. There was loads of them in NuGet, unsurprisingly, but I picked this one. Don't know why. I think it was the most number of downloads. And I started to work on another Lambda function, and this was running locally, a Lambda emulator at the time on Windows. This was the brief: create a thumbnail for any video that doesn't currently have one, and then put the thumbnail images back into the S3 bucket and delete any temporary files that you've made along the way. And then on completion, call the existing Lambda function to recreate the video list. And there's some shared code from the S3 stuff. So I got this working on Windows on the hundreds of videos that were already existing, got the thumbnails up there, and then I changed the list generation code so it would now only show videos that had a thumbnail available. So if a new video goes up, it's not going to appear on the website until this thing's run. But this worked great on Windows, and I thought, well, there's a bit of a problem here. Like, Amazon aren't going to want to let me upload a third-party piece of software to run as an executable to manipulate videos. So how can we get around this? Well, there's something on AWS called Lambda Layers, which is a marketplace of additional software to add onto a serverless function, and there's one in there called FFmpeg Lambda Layer. Fantastic. And it's dead easy to deploy it. You deploy an instance of the Lambda layer to your environment, and then you go into your function and you click add layer and you choose it, and it worked. Fantastic. Did some website alterations. The first one was to incorporate the video tags, the poster graphics. I had some cosmetic and mobile improvements to do. So this website had been rushed to the finish line for this advent calendar, and I now got the opportunity to improve it slightly. I started to write an editor's notes thing, so the website's divided up by year, then by month. But if you visit in January, I wanted to say, there's no hedgehogs because they're hibernating, but there's some mice on this day, and a badger came in the garden on this day, or whatever. And then on months of interest, I can say, oh, look at the 17th, because there's some nice footage on that. And I added an FAQs page because people were asking questions about cameras and the process, and yeah, it just started to look a bit neater. That's kind of the calendar view. And yeah, the Raspberry Pi bit, it was always an aspiration, but there was a shortage of electronics caused by the pandemic, and you could not get hold of these things unless you went on eBay and paid silly money. So I think I was monitoring eBay, but I set stock alerts on the various IoT websites to tell me when things came in stock. It needed to run .NET. At the time it was .NET 6 or 7, which needed a 64-bit Linux operating system. So in Raspberry Pi speak, that was a Pi 3 or 4, now a 5, or a 02W, the lower powered device. And just after Christmas I managed to get hold of a Raspberry Pi Model 3 from the Pi Hut, Model A+, and it was about 37 quid, and I added my own SD card and power adapter. I still find that pretty exciting, that you can buy this really quite powerful device for not much money, and if you go for a Zero or a Nano, then it's even cheaper. The barrier for entry with tech used to be really high, and it's now pretty low, really. So anyway, I got hold of this, and I needed to install Linux. So I picked this version, Raspberry Pi OS Lite, and it's based on Debian Linux, and the Lite denotes that it's not got the desktop UI. I don't need the interface with the mouse. I'm happy to work with just command line interface. Installed it with the Pi Imager app, which is on each platform, and you get it from raspberrypi.com, and it's dead easy. You just load it up, stick your SD card in, you navigate a few screens to find the operating system you want, and then you go back to the main screen and you click write. It takes about 2 minutes, and then you can eject the SD card immediately, put it in your Pi, and it would boot up at that point. But what about .NET? So I appreciate not everyone here is maybe familiar with .NET, but .NET is a runtime environment, a bit like Java runtime. If you want to run apps that depend on the runtime, the framework, then you need to install the framework. So you can install .NET, and at the time I had to choose between 6 or 7. Even numbers are long-term support. You get 3 years of support from Microsoft, and odd numbers are short-term support, 1 year of support. So .NET 10's out next Tuesday. That will be a 3-year supported product. And there's official documentation from Microsoft about how to do this, or there's another MVP, Pete Gallagher. He's got a one-line installer, and you can go to his GitHub, pick your .NET version, and it gives you a one-line code that when it runs, it fetches all the dependencies, cleans up any prior versions, and sorts it out for you. So either approach really, or, and this is what I actually did, you can run self-contained apps that don't depend on the framework, so you don't need to install .NET. Most of the Linux distributions have got .NET shipped in them now, so you don't have this dilemma, but I thought this was kind of neater. I can compile down to a single executable and just run that on the device, and then publish via a command line. So .NET publish, runtime Linux ARM64, and self-contained. And you can do this from a published profile in Visual Studio if you prefer. So we've got .NET 7, self-contained, Linux ARM64, produce single file, so it won't produce a file for each package, you'll just get one. And there's another tick box at the bottom, it says trim unused code, and I found that one a bit hit and miss. So sometimes it would work, and it sounds like a good idea, get rid of the bits of the framework that aren't in use, but sometimes it would deploy. I'd try and run it and it just did nothing, so proceed with caution on that one. And then, yeah, to deploy it, I'm using scp command on the terminal. So I'm saying take the code, the compiled code from this blue folder on my PC, and put it in the folder on the right hand side on the Raspberry Pi. Raspberry Pi is the host name of the Raspberry Pi. It could be an IP address, it could be a different name, and administrator is the username on the Raspberry Pi. So if all that works, then you'll immediately get prompted as we needed. So the S3 stuff, not much needed changing. It was Linux file paths are different to Windows file paths. The slashes are forward slashes instead of backslashes. And this caused some problems. There's a function called enumerate directories in .NET, and that struggled with this. If I give it a big long name with a full path, then enumerate directories refuse to acknowledge that this was a pathed file name and thought the entire thing was a file, and consequently failed. So the dirty fix here was just to switch a backslash for a forward slash, and that worked. But the camera experiment stuff, this needed lots to be changed, and it was all the good stuff, the Wi-Fi and Bluetooth stuff. So neither of the packages were compatible with Linux. And when .NET first went cross-platform, this was the case with lots of packages. It's less the case now, but if you are doing hardware-specific things, then you will come across this. I thought, well, what do other people do? So I went back to GitHub and I started looking at Python packages for IoT, and I noticed that lots of Python packages call out to other Python packages, and lots of other Python packages call things on the command line to do things like Wi-Fi. So I thought, well, can I do that? Well, I'm going to call the Linux CLI using processes in .NET. And yeah, again, you might not be able to read this, but the block at the top says start a process, and we're going to call a shell file, bluetoothlinux.sh, and we're going to pass in the parameters like the wake up command and the ID of the device. And this is a program that you would have typed in the terminal. So we're going to pipe the output from the command back to the process in .NET as a string. So, and then I'm going to examine it when it's finished, and if it's got the words written successfully in the string, then I know that the command works. I wanted this to run automatically when the Raspberry Pi booted up, so I found this file called etc.local, was it? No, rc.local, and I wanted it to boot automatically. I wanted a timer switch in the room that would turn the Raspberry Pi on at 7 AM and run this thing, and then close off at 8 AM. But I didn't want it to run if I turned it on later in the day, because that would probably be me coming in to alter the code. So I'm saying if it's below 11 AM, then run this script file, automation.shell. Otherwise, just boot up as normal to the command line. But what I found was, once the power's been cut to the Raspberry Pi, it loses the date and time, and it doesn't always get the date and time back immediately. So the internet process that runs to get the date and time sometimes happens after it's booted up, very slightly. So the first thing I'm doing in the file is going to the internet and saying get the time, and then do this thing. So if it's before 11 AM, it then runs this file, starts the network manager, switches to the camera experiments folder. Now there's 3 files in there, the actual executable and 2 shell files, and I'm just telling it to change the execute permissions on those files to make them executable, because if I've shipped a new version, it will arrive in kind of plain format and won't be able to be executed. So set the permissions and then run it. And then that thing will run, might take 5 minutes, and then it'll finish. And then switch to the the bucket experiments folder. Again, set the permission on the file and then run it. And then that might take another 10 minutes. And then when that's finished, it's commented out there at the bottom, but then power down the Raspberry Pi. So timer switch brings it on at 7. This thing might run for 25 minutes or something, and then it'll shut down, and then the power gets called at 8, hopefully quite a bit further after the actual process is finished. And this is in the computer game advert style. It's a sequence shortened version of this, which I'll try and explain. So it finds this camera, CY95, does the Bluetooth bit, connects, manages to connect to the Wi-Fi, finds all these files, downloads them all, disconnects to Wi-Fi, reconnects to the home, the local Wi-Fi, goes back to the folder, and then starts pushing the files up to Amazon S3, and then it finishes, and then the Pi goes off. And this worked surprisingly well, but not every day. So the Pi was on the windowsill, and the Hedgehog house was maybe 2 or 3 meters away outside, but on a windy day or something like that, the signal would be disrupted, because it's not like it's not as powerful as your home router or anything like that. Yes, it's got a Wi-Fi network, but it's extremely low powered, and it would fail. So I wrote another Lambda function to give me some alerts. It sends me an email if either there's no new footage or there's footage in the uploads folder that needs my attention. And this runs at 11 o'clock. So Pi comes on at 7, does some stuff, shuts down at 8. Stuff might continue to run in the cloud for a while to process this stuff. And then this runs at 11 and would send me 1 of 2 emails to either say nothing's happened today, or there's loads of files that need your attention. And then that spring the Hedgehogs came back. So they came back about March and visited a lot to feed up, less so in the summer, and we wouldn't come on extremely hot days, but in the extreme of summer they would come at maybe 10 o'clock at night and 5 a.m. when it was still light. So we did get some colour footage as well at those sort of times of day. Over the spring summer, I got hold of these things called Toshiba flash air cards, improved the outdoor setup, and I got working on motion detection and image recognition, and added a screen onto the Raspberry Pi. So what's Toshiba flash air? Well, these are full-size SD cards with built-in Wi-Fi. So this thing will transmit a Wi-Fi SSID from within the SD card, and you can use this to wirelessly enable any device, any camera, anything. But they are full-size SD cards, so if you want to put it in a camera that's got a micro SD, then you need a little ribbon cable and adapt it to go back in. And again, it's got a built-in web server, and in this case it's a CSV file. Got all the cameras going. The one with the solar panel replaced the Arlo, which went back on the home security system. I had timer switches outside because this stuff only needed to run kind of at night time. It was all running off a central battery stuck inside an old bird tabletop that had dilapidated underneath the child slide, and it was being powered by the solar panel that came with the outdoor camera, charging a little battery pack. So one of the first times I did this talk, somebody said to me afterwards, oh yeah, have you thought of motion detection? And because you're running on AWS, have you looked at I've made a misstep here. Motion, that's recognition. Yeah, motion detection. So the little white camera that was inside the Hedgehog house, this one was a little bit dumb in that it just recorded constantly in 5-minute blocks, whether there was anything there or not, all night long. So I was having to go through these and say no, 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 yes, yes, yes. So I thought, well, I can automate this with motion detection if I know that something's happened in the clip. So it's this camera, and I'm doing it by comparing the first and the last frame. So blur both images, so make both images and blur them, and then I reduce the size to 16 by 16 pixels, which sounds really small, but if you do it any bigger, then the chances of artifacting or anything else on noise on the image being different is quite high, and you won't detect everything will report as a change effectively. So this is how it would look. And this runs in a Lambda function, and the advantage of running this on AWS is it's got direct access to your bucket, so you don't need to write code to download the file for it to then run its thing and then delete the file and pay for that transfer or anything. It's got direct access. So it's specifically for the field camera and the outdoor camera with the solar panel, and it would auto approve hedgehog phrases and discard cat, and everything else would still go as manual. So what do I mean by phrases? Well, you won't be able to see this perhaps, but hedgehog could also report as porcupine or armadillo. So that's fine, I can deal with that. Rat, rodent, hamster, mouse, that's a mouse, I'm interested in that. Cat was cat, so I knew at least for cat I can just delete that. Strong identification, delete file. This is a sample from the AWS website demonstrating this. So there's a picture of someone on the street, and it's got city, road, street, urban, person. If you change it to a different image, it's got a cityscape and it's got architecture, building, cityscape. Okay, what about hedgehog? Well, it's got hedgehog, mammal, porcupine. This is how I knew about porcupine and armadillo. What about a mouse? Well, for a mouse, it could report mammal, rodent, rat. For some reason, it came up with computer hardware as well. I suppose it is a mouse. back to the hedgehog. If you look at the response data, then it tells you exactly what it found, when it found it, the position in the file, coordinates-wise. So you could use this data to create one of those apps that puts a bounding box around things and identifies them. And yeah, it's quite cheap. It is time consuming to run, but I worked it out. I added this mini screen to the Raspberry Pi, one of these for whatever reason, and I programmed this using the image sharp library again, and it shows either the progress of the morning's work or the fact that it's switched on and in debug mode because I've got it on to do something. And it took me a while to work out the pinnage and the programming to get an image onto this thing. It's all or nothing. Most of the time it's nothing, but you eventually get it right. And then I encased this thing in Lego, and the Raspberry Pi was behind it, and that was on the windowsill, and the hedgehog house was maybe 2 or 3 meters away. And the kids thought this was fantastic because they'd come downstairs and this thing would be running in the morning and look hedgehog on it. And it would also alert me if it was getting to like 7:45 and it was still stuck on downloading footage. I knew that it had crashed, and I could run a command to shut the Pi down gracefully before the power got terminated. And then I took this thing on tour in 2023. So where have we got? I've got Macclesfield, Manchester, Liverpool, Leeds, Sheffield, Bristol, and then I did Manchester Tech Festival at the end of 2023 at the People's History Museum, and it kind of felt like the natural finishing place for this little tour, and I was just about to start a full-time job after this point, and previously I'd been a freelancer for many years, and possibly that's how I found the time to do a lot of this stuff, but I kind of stopped doing it at this point, and 2024 became the beginning of the end. The hedgehog house was getting tatty and the tech was starting to fail. The domain name was up for renewal, so I'd got it for 2 years on Fasthosts or wherever it was, and it was up for renewal. I decided not to renew it, and I would end the project by the winter. So I adjusted the website to run back at the GitHub page's standard URL rather than the domain name, and I needed to change the website slightly because that runs a folder up rather than on the root, so needed to adjust a few things and kind of shut it down, changed the website to have an archive message on there. It's still up there, but people were still asking me about it, and people were coming up to me and saying, "Oh, you're the hedgehog guy." So earlier this year, I decided to take this back on the road. So I went to Stafford in the summer, and I did it online for .NET Knots in September, and here I am today. And people still want to hear this story. It's an old system, and I don't know what the future holds for it, but I've still got this Raspberry Pi that I'm going to do something with at some point, and it was a project that came from nowhere, and I just found the time to evolve it. And I would encourage you, if you've got a hobby project, go and do it. You'll waste tens, hundreds of hours doing this stuff, and you'll go down several dead ends and abandon things, but when you do get something working, it's really satisfying, and people still talk about it. That's kind of it for the talk. The web page is now there. The slides are on GitHub, which is where this QR code goes, and all the links and references to packages, for blogs, everything else are listed in the README file on GitHub. You can find me at the usual places, and if you look at my blog, it's got the original article, .NET IoT and Hedgehogs, that was on the advent calendar, and there were 2 further blogs which described all this additional automation and screens and everything else, and that's kind of me. So has anyone got any questions?
What are the monthly AWS costs if they're running this?
So S3 is very cheap. You can put lots of stuff in S3, tens of gigabytes of stuff, and it kind of doesn't cost anything until you request the files. So it's if people visit the website, then it can start to accrue costs. But you do get an allowance of 100,000 or 1 million, some ridiculous amount of requests per month. Lambda can accrue costs, and the recognition service, that was probably the most expensive bit. Yeah, it wasn't costing me huge amounts of money. I've got a virtual machine on AWS that runs my website and various other websites, and that VM costs significantly more than this Hedgehog stuff was costing. As it was kind of architected by accident, it wasn't architected in a way to bring the costs down, so it probably wasn't a sensible way to do this thing. But there is a free tier on AWS and there is on Azure, and you can run lots of stuff for zero cost and very rarely raise a bill from the service. I'm sure if you work out what Microsoft and Amazon and Google and various cloud providers run for a hobby project, you could put various things in various places and keep it free kind of indefinitely. So.
Do you know when you were doing the motion detection? Obviously you like comparing one frame with another frame. What was your kind of time periods of that? Because, say if it's someone walking past your door or something, that might happen in 30 seconds, but for a hedgehog,
it was only this one specific camera that was inside the Hedgehog house, and it would record in 5-minute chunks. So each MP4 file was 5 minutes. So it was the first and the end frame, and I was looking for little bits of biscuit changed from it, because I was previously manually looking through these things, fast forwarding to the end and seeing, has anything changed? And yeah, I was looking out for bits of biscuit. So so that's and a mouse might run in and take one biscuit and go again. So that's the kind of.
And did you get any noise with that, like changes in light?
You do get misreported stuff to do with light, or just the artifacting on the MPEG file, and that's why it's blurred and then reduced to that very tiny size. And if you at 16 by 16, if you go 32 by 32, then the number of errors that get reported, even at that size, are significant. So that's why I stuck to this 16:16, which sounds tiny, but it did do the job. And I knew that because it was self-contained in this box, if there was a change, it was likely to be something that interested me. So.
If you were to be inspired to do this today, what would you do differently?
So there's a guy called John Staveley that runs Leeds Sharp, and he wrote a system for birds, and his system pushes everything up to the cloud immediately and then does all the processing using Azure Cognitive Services to decide if it's a bird or not. So I'd maybe try and run less stuff in code and get stuff up there immediately. I'd maybe look at the official Raspberry Pi cameras as well, because I was using commercial cameras just because, well, that's what I had access to. So the kit and the system were never a perfect match, and they could be if I was to design this thing. So there was a hand at the back.
Quick comment on that. Yeah, with IoT, things are changing so fast. The cameras appeared that weren't there 2 or 3 years ago. So my question: what switched the Pi on and off? Was it one of those timer things?
It's like one of those traditional timer things, but it's got an LED. It's got a screen on it, so at least like a digital watch, you can set the on and off time. The Pi 5. one of its super features is it has actually got an on button now, so you can actually shut it down. Whereas all previous Raspberry Pis, you couldn't switch it off unless you had issued a command, and if the power got moved, then it would go off. So that's a big improvement that they put an on button on it now. So.
But having that device means it's completely powered off rather than it having some sort of trigger causing it to wake up.
No, it's it was on the timer from this plug, and then so it came on at 7 a.m. and did its code, and then say it was finished by past, then sudo shutdown ran in Linux, and then it would shut down, so it would still be on, but operating system's off, and then it's safe to cull the power at that point. Whereas, you realise this when you get one and you're experimenting with it, that you do end up pulling the power out a lot, and then it boots back up and complains like Windows would that something might be corrupt at this point. So yeah, you learn this pain, unfortunately. So. Yeah, well and there wasn't that in place, but once I had the screen and I was getting ready for work at this point, I could see whether it was still on, because the screen would go black if it shut down, and if it was still on at 10 to 8, then I'd have to stop what I was doing and get this thing to shut down. So. Cool. Thank you very much.